Okay, so our goal is to look at the structure of the atom and look at how it's kind of evolved over the last couple hundred years. There's been many theories of the atom, and what we're going to look at is the individual parts and their discoveries that kind of created these different versions of the atom. Technologically speaking, this is an ideal situation, but I'm going to do my best where you guys can see video and we'll just see how it goes. All right. So first off, by the late 1700s, early 1800s, most scientists had agreed that elements were made up of these little particles called atoms, and that each atom was unique in deciphering the difference between something like carbon or something like iron or something like gold. There was something different about them. They had no clue what was different, but they did know that there was something different about them. And our goal is to look at the different discoveries that led us to kind of where we're at today and how we know the difference between something like carbon and gold. Um, One of the first theories is that they were individual spheres, and I mean, I call it the gumball theory. Um, they didn't know exactly what was going on with those individual spheres, but their ideas were, there's these things. We're not sure what they are. They're very small, and there must be something that's slightly different. John Dalton's one of the first scientists that came up with this theory of these being individually spheres. What I want you to do right now is just take a second and just in your notes, draw what you think an atom looks like. And I'm going to put some of my great artwork on the board here in a second, just to kind of see where you're at with that. So I'm going to give you guys a couple minutes to figure that out. All right. Well, curious to see what you guys kind of drew. Most students, when asked what an atom looks like, they might just go straight gumball. Okay. Um, they might do, I call it the Jimmy Neutron one, where it's kind of like these little particles, and you got like these electrons going here and here and here. Jimmy Neutron, right? Jimmy Neutron theory. I don't know. That's kind of what um, this is a positive charge, and these things out here are negatively charged. So one of the things that most of you guys are going to probably put down when you think about that. We're going to look at kind of what we think it looks like and what these different scientists thought it looked like over the years. So one of the keys for understanding what an atom is what's in it. And so I don't know if you guys can see here, the video shows somebody charging a balloon and watching the stream of water kind of bending. And why does that happen? And there's lots of different reasons, lots of different ideas that we're going to kind of come across in this class. But here's kind of one of the fundamental things I want you guys to know. In science, this is one of the, if you remember 5 things that I tell you, this is probably one of the 5. Opposite charges attract each other, and like charges repel each other. So things that are similarly charged are going to push away from each other, and things that have opposite charge are going to be attracted to each other. So for whatever reason, this balloon and the water must have some particles in them that have opposite charges, because you'll see the stream of water, it kind of converges in the proximity of the balloon. So one of those fundamental things that we want you guys to know kind of throughout this section and down the road. If you can remember that, you're going to be in good shape. Okay. When the first particle that was found in the atom was the electron, and scientists that has given credit for this is a guy by the name of J.J. Thomson. Used something called a cathode ray tube to discover the electron. I'm going to show you a current kind of I don't know, a video on YouTube of a cathode ray and kind of how it does its thing, where you see the stream of particles throughout. So give me a second here. Let's see here. We'll go cathode ray tube, and I'll blow this up so you guys can see what's going on. Hopefully this comes out.
This is a cathode ray tube. Inside, there's nothing inside. It's actually a vacuum tube. So there's nothing but a vacuum on the inside. And it's called a cathode ray tube because this is the anode and this is the cathode. When it's hooked up to an electric current, like I'm about to do here, you can see a beam moving across. You might think it's light, but when you take a magnet to light, does it do this? You can see that it's bending or deflecting away from the magnet, so we know that it's not actually light. What J.J. Thomson summarized was that he was seeing a piece of an atom flying from one end of the cathode ray tube to the other, and the piece of the atom that he was seeing was negative based on the end of the magnet that was causing a repulsion. So the negative ends of the magnet was causing repulsion, therefore the particles must be negative.
So J.J. Thomson used this cathode ray tube, and what he found was that they were full of these electrically negative particles. He coined the term electron, and they discovered the electron here, small particles that are negatively charged. The way they knew that the negative charge occurred from the electron was it was deflected by a negatively charged plate. So opposite charges attract, like charges repel. So it kicked it out. And this is what we call the plum pudding model. So the plum pudding model is a model. Just go back a slide here so I can show you guys how this works. Plum pudding model, I call it the chocolate chip cookie dough model. Basically, they hadn't discovered anything about the positive charge, so they kind of thought it was a lump of positive charge, and then there was like these little chocolate chips kind of mixed in. And these chocolate chips had negative charges. So plum pudding was something that they ate in England, where they never had it. Kind of sounds gross. I don't know what to tell you, but the plums or the raisins in the pudding were the negatively charged particles. But you know, we're big fans of chocolate chip cookie dough, so we call it the chocolate chip cookie dough model for us. Okay, so a few years later, scientists by the name of Ernest Rutherford did a gold foil experiment. I'm going to show you right now. And Rutherford was a chemist that was kind of Thomson's understudy, and found some interesting findings by shooting a bunch of particles at a gold foil. Gold is a very, very malleable thing, and it is only a few atoms thick. So I'm going to show you guys the gold foil experiment.
Its heart is the oxide-coated cathode.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there.